Alright, we go to section 1.5, applications of linear equations and modeling. We've already done a little bit of work with slope, and with slope-intercept form we're going to present point-slope form in this. Two things you must have to find the equation of a line. You must have a point on the line, and I like the y-intercept when possible, and you must have the slope of the line. So we use the point-slope form, which is derived from the slope formula itself. The point-slope formula for a line is given by y minus y sub 1 equals m times the quantity x minus x sub 1, where m is the slope and x sub 1 y sub 1 is a point on the line. So if I have the slope and I have a point, I can plug into here and I can write the equation of the line. Here's an example. Use the point-slope form to find the equation of a line passing through the point -5, 2 and having slope -3. Those are the two things I need. I need a point on the line and I need the slope of the line. And I'm going to write my answer in slope-intercept form. So after I use point-slope form, I'm going to rewrite this into slope-intercept form, which you remember is y equals mx plus b. So I'm going to start off here. I'll write this down again. You're going to need to remember this one. Comes in very handy when writing the equation of a line. I'm going to substitute -5 and 2 in for x sub 1 and y sub 1 respectively, and -3 in for m. So I have y minus 2 is equal to -3 times the quantity x minus -5. Well, when you subtract the -5, that's the same as adding +5. So that's my equation, but they want it in slope-intercept form. Remember, y equals mx plus b. So I have to solve for y, and I'm going to first simplify the right side by distributing. I have y minus 2 is equal to -3x minus 15, and then I'm going to add 2 to both sides. Y minus 2 plus 2 is equal to -3x minus 15 plus 2. Bring it over here. I have y is equal to -3x minus 15 and plus 2 is minus 13. And that's the answer that they're looking for. Now here's a slightly different example. They don't give us the slope. It says write the equation of a line that passes through these 2 points. Well, I need a point and I need the slope. I have 2 points. I don't have the slope given to me, but remember, if you're given 2 points on the line, 2 distinct points, you can find the slope using the slope formula. Y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So if I call this x1, y1, x2, y2, I would get -3 minus a -5 all over 7 minus 2. So that's going to be -3 minus a -5, +2 all over 5. My slope is 2/5. I can take either point, it doesn't matter which. I'll just take the first one here, and I'll plug into point slope form. So I have y minus a -5 is plus 5 is equal to my slope 2/5 times the quantity x minus 2. And I can stop right there. It says write the equation of a line. It doesn't say to put it into standard form or to put it into slope-intercept form. I'm just going to stop right there. If you take the extra steps to put it into slope-intercept form, maybe you're planning on graphing it, that's fine. But if you don't have to graph it, you can make a silly mistake, leave it into this form. Now, 2 key ideas about slope, slopes of lines and lines that are parallel or lines that are perpendicular. Now, remember, slope describes the way that the line is slanted. Positive slope, the line goes up and to the right. Negative, it goes up and to the left. Horizontal lines have slope equal to 0, and of course vertical lines, their slope is undefined. But we can get an idea about the way the line slants, the way the line is angled, by knowing the slope of the line. So if I have parallel lines are angled the same way. They have the same slant. Therefore, they have the same slope. Look at number 1 here. If m sub 1 and m sub 2 represent the slopes of 2 non-vertical, because vertical lines don't have slope, parallel lines, then the slopes are equal. M sub 1 must equal m sub 2. That kind of makes sense if you think about it. Same slope, same slant, parallel lines. Now, perpendicular on the other hand, perpendicular lines form right angles, so they're not going to have the same slope, but there is a relationship that you should remember about perpendicular lines and the slopes of those lines. If m sub 1 and m sub 2 represent the slopes of two non-vertical perpendicular lines, then m sub 1 is equal to negative 1 over m sub 2, or the product of the slopes is negative 1, which means, as you can see here, the slopes are opposite reciprocals. Opposite reciprocals, they have different signs, and of course you remember what a reciprocal is when you kind of flip the fraction around, a over b, b over a. So remember these two things, they'll come in handy. Here's a couple of examples. The first example says write the equation of a line that passes through the point negative 3, 2 and is parallel to the line defined by x plus 3y equals 6. And we're to write our answer in slope-intercept form and standard form. I need two things to find the equation of a line. I need a point and I need the slope. I have a point and I have the ability to find the slope because it's parallel to this line. I'm going to take x plus 3y equals 6, and I'm going to rewrite this into slope-intercept form so I can identify the slope, because the slope of this line is the slope of the line in question. So I will subtract x. Hopefully I left myself enough room. I'm going to rewrite 6 minus x as the opposite of x plus 6. I'm going to divide through by 3. I'm kind of running out of space here, so I'm just going to kind of connect it here. Cheapen out a little bit. And I get y equals negative, or the opposite of x over 3, which is like a negative 1x over 3, which is negative 1/3 x plus 6 divided by 3 is 2. This is all I need. I need the slope of this line, the given line, because the line that I'm looking for is parallel. It has the same slope. So now I have everything I need. Y minus 2 is equal to negative 1/3 times the quantity x minus a negative 3, or x plus 3. That's the equation I'm looking for. And I left lots of space here because they don't want the answer written in this form. They want slope-intercept form and they want standard form. And I already see a fraction coming my way, so I'm going to have to do something with that for standard form. But to get slope-intercept form, like I did before, on the first example over here, I'm going to distribute. I have negative 1/3 x, negative 1/3 times plus 3 is minus 1. And then I am going to add 2 to both sides. And y minus 2 plus 2 is equal to negative 1/3 x minus 1 plus 2. So I have y is equal to negative 1/3 x plus 1. And that's my first answer. That's the slope-intercept form. Make that look like an x a little bit better. Now to put it into standard form, remember standard form is ax plus by equals c. No fractions. And a and b are not both 0. I am going to multiply through by 3 to get rid of the fractions. So I have to distribute. I have 3y is equal to, the 3's will cancel. I'll get the opposite of x plus 3. Now I'm going to add x to both sides. I'll put it out in front on the left one over here, on the left side. And I'll put it out in front over here as well. So you can see that these x's cancel, and I have x plus 3y is equal to 3, and that is the second part of my answer. Now, I didn't leave myself much space here. I really didn't leave myself much space here, and I hope you can still read it with all my work above it. I am going to definitely need to clear some space out over here to be able to work this next problem. Write the equation of a line that passes through the point. Again, they give me the point, that's good, and it's perpendicular to this line. Well, what's really convenient about this example is that the line that they give us, unlike here that was in standard form, is already in slope-intercept form, and I can identify the slope as 1/6. Now, if it's perpendicular, it is the opposite reciprocal, so you flip it and you change the sign. So if I take 1/6, flip it, I get 6 over 1, or 6, change the sign, I get negative 6. So the slope that I'm looking for in this problem is negative 6. Now, it doesn't say how to write the equation of line. It doesn't say to put it into slope-intercept form or anything like that. So I'll probably just leave it into point-slope form, because I have those two things. So now, over here, here's point-slope form. Y minus a negative 4 is plus 4 is equal to my slope, which is negative 6, times the quantity x minus negative 8, which would be plus 8. And maybe I would have had enough space underneath there, but there we go. Y plus 4 equals negative 6 times the quantity x plus 8. Again, if you want to graph this, you're better off rewriting this into slope-intercept form. Otherwise, just leave it as is.